Your fat client is a black box. I'm the server that lets AI see inside.
When we're modernizing apps, AI agents have this huge advantage on the web. They can use things like the Chrome DevTools Protocol to get full programmatic access to an application's state. But what about legacy desktop systems? Those fat clients running critical business functions? Well, that's a totally different story. They're just black boxes, and the existing accessibility APIs, they just weren't built for this job. The serialization, the transport, the granularity, it's all wrong for any kind of deep analysis. So today, we're going to dig into why that observation gap is the real reason rewrites fail, and explore a universal pattern to fix it. It's funny, in any big legacy rewrite, all the attention immediately goes to the back end. But here's the thing. Server-side code is a tractable problem. It's got defined inputs, outputs, and state that you can actually trace and log. The server is solvable. The real chaos, the part that absolutely sinks projects, is the fat client. That thick, stateful desktop app where years of unwritten rules and behaviors are just hiding in plain sight. So here's how we're going to break this down. First, we'll pinpoint the real rewrite problem, and it's inside the client. Then, we'll define the desktop observation gap this creates. After that, we'll get to the solution, a self-describing application, and explore the awesome new workflows this unlocks. And finally, we'll wrap up by showing why this isn't just some one-off fix, but a truly universal modernization pattern. Okay, so the true complexity of a legacy system. It's not sitting in the database schema or in the server-side business logic. Nope. It's embedded right there in the user interface, in that complex dance of components that users have been interacting with every single day for years. Just look at the contrast here. Server code is pretty linear, right? A request comes in, data flows through known paths, and state is persisted in a way we can see. But a fat client? It's this intractable web of event handlers for clicks, key presses, timers, you name it. Its most critical state lives entirely in memory, completely unlogged and unqueryable, changing hundreds of times a second. And this is what creates the tribal knowledge trap. The real business logic isn't written down in some design doc. It's the emergent behavior that's evolved over years of use. It's in all those subtle workflows that users can't even articulate, but if you took them away, their entire process would break. For these systems, the only source of truth is the running application itself. Which leads us straight to the core issue, the desktop observation gap. The fundamental reason these modernization projects stall out and ultimately fail is that we are literally trying to rebuild a system that we cannot fully see. This right here is the central rule. You cannot rewrite what you cannot observe. It's as simple as that. If you can't programmatically query the intricate state machine of the user interface, if you can't map out every single user workflow with certainty, you're just building blind. And building blind guarantees you're going to miss critical features and completely alienate your users. For web developers, this problem is basically solved. Tools like the Chrome DevTools Protocol give any external process complete, programmatic access to inspect the DOM, read state, and fire off actions. But for desktop apps, we're left with a black box. Our best tools are often these fragile, pixel-based screen scrapers. It's not great. And let's be really clear here. Accessibility APIs are not the answer. They were designed for a totally different purpose, to help screen readers. For the kind of deep analysis and automation that modern tools need, their serialization format is wrong, their transport layer is clunky, and the level of detail they provide is just not good enough. So if the problem is a gap in observation, the solution has to be about creating visibility. And this brings us to a simple yet incredibly powerful architectural pattern that finally gives the application a voice. Here's the pattern. The application becomes self-describing. How? By embedding a lightweight HTTP server right inside the application's process. This allows it to expose its own live UI state as structured, queryable JSON to literally any HTTP client. This one simple change creates this profound transformation. The application is no longer this opaque box that you can only poke at from the outside. It becomes a transparent system that can tell any client, a test script, an AI agent, a developer tool, exactly what it's doing, what state it's in, and what's possible at any given moment. So how does it work technically? Well, it's pretty straightforward. You embed a server. When a request comes in, it safely accesses the main UI thread, walks the live component tree, serializes the state of every single UI element into structured JSON, and then serves that data up over a local port. The real beauty of this approach comes down to a few key design choices. It's embedded, not external, so it has perfect, instant information. It uses a flat JSON structure, which is way easier for AI models and simple scripts to work with. It adds zero new dependencies using built-in libraries, and critically, all UI access is handled in a totally thread-safe way. All right, so now that the application is fully observable, what can our teams actually do with this? The practical benefits are immediate and they are substantial. Let's start with QA. This new observability just completely transforms testing. Instead of writing those brittle, coordinate-based automation scripts, test cases can now be defined in plain English for an AI agent to execute against the application's actual semantic state. The shift is just massive, from fragile to robust. The old way relied on screenshot comparisons and clicking screen coordinates, which break all the time. The new way lets an agent perform a semantic action, like click the submit button named submit_order, and then verify the result by reading the application's actual structured state. It's precise, it's repeatable, and it doesn't break when you move a button. And this goes way beyond just QA. Business analysts basically get a superpower. They can now programmatically query the application like it's a database to discover every field, every dropdown, every menu option. They can record real user sessions to see what people actually do, not what they think they remember doing in an interview. And they can validate requirements against the live running system. Now, while the java-swing-mcp project is a great example of this for Java Swing, it's really important to understand that this isn't a framework-specific trick. This is a fundamental modernization pattern. It doesn't matter if your legacy application is built in Java Swing, .NET's WPF, C++ with Qt, or even old-school Win32. The core ideal holds true. As long as you have access to the source code, you can instrument the application to describe itself. Look, the specific code to walk a WPF component tree is obviously going to be different from the code for Swing, but the pattern, embed a server, walk the UI graph, and serve structured state over HTTP, that is a universal solution to the fat client observation problem. So I'll just leave you with this question. What could your teams accomplish if those critical, complex legacy applications were no longer opaque black boxes? What becomes possible when they can finally tell you exactly what they're doing at any given moment? That's the power this pattern unlocks.
The implementation is Swing. The pattern works everywhere.